Hello everyone, welcome to BW. Good evening everyone. Please let me know by writing in the comment section whether audio and video everything is perfect or not. Please let me know by writing in the comment section beta ji whether audio and video everything is perfect or not. Let me verify from my side as well. Whether audio and video everything is perfect or not, please let me know by writing in the comment section beta ji whether audio and video everything is perfect or not. Okay, great. Now it is perfect. Great. Thank you everyone for the confirmation. So now we are on lecture number 10. Basically, this is your lecture number 10. And in this lecture, we are going to discuss most important part of your entire sequential circuit. In this we learn about designing of some new flip-flops. Is it okay? Great. So now please observe. Till now we have covered SR flip-flop. We know how to construct SR flip-flop, the working of SR flip-flop, truth table of SR flip-flop. Also we have observed excitation table of the SR flip-flop, and a disadvantage: SR flip-flop will have invalid condition. Today I am moving towards JK flip-flop, then we will move towards D and T flip-flop, and at the last I am moving towards the designing of new desired flip-flop by using available flip-flop, or another way you can also say conversion of one flip-flop to another flip-flop. Is it okay? Great. So let's first discuss about JK flip-flop. Please observe, so this class is very important because just after this class you will be able to design any kind of desired flip-flop. Now if we talk about JK flip-flop, JK flip-flop can be represented in this way: JK QN complement. In front of J we have QN, and in front of K we have QN complement. Is it okay? And we have a clock. Is it okay? Great. Instead of using a clock normal, we use edge triggered clock. Okay, I will discuss about edge triggered clock very soon. Let us first discuss about the level triggered JK flip-flop. Okay. Now if you observe how this JK flip-flop is designed, this JK flip-flop can be designed by using SR flip-flop only. So we all know about SR flip-flop, and we all remember about the truth table of SR flip-flop. So in SR flip-flop, if we use one AND gate at the input of S with one input connected as QN complement, another input connected as QN to the K. Okay, another AND gate. So we have J and we have K. Now this is basically your JK flip-flop. So JK flip-flop can be designed from the SR flip-flop. JK flip-flop can be designed by the SR flip-flop. What is S? You can say, sir, it's a JK flip-flop. Now if you observe, what is S? S is equals to JQN bar and R is equals to KQN. How many of you able to understand up to this part? Please let me know by writing in the comment section, beta ji. How many of you able to understand up to this part? Please let me know by writing in the comment section. Great. So in order to understand the JK flip-flop, we need to construct truth table. We all know about the truth table of SR flip-flop. Hoping all of you remember. I am just making a rough of the truth table of SR flip-flop at the corner. Please observe here. So we all know about SR flip-flop, sir. In case of SR flip-flop, we have a clock as well. In case of SR flip-flop, if the clock is high, if the clock is high, then only depending upon S and R we have the next state output. In case if the clock is low, irrespective of S and R, your next state will remain same in the previous state. So with a high clock pulse, we are getting 0, 0, 0, 1, 1, 0 and 1, 1. It means total 4 possibility of S and R. And if 0, 0, we get hold state. For 0, 1, we get reset state. For 1, 0, we get set state. And this is your invalid state. So, hoping all of you have remember SR flip-flop that I have discussed yesterday. Now come back to this. So, internal circuitry will remain same. Only the thing is, J into Qn bar is going to S and K into Qn. Input K into Qn. Qn is the previous input and we are interested to identify the next state Qn plus 1. Is it okay? Yes, sir. Now, in order to understand functioning of JK flip-flop, we must need to construct its truth table. So let's have a discussion onto the truth table of the JK flip-flop. Now please observe, we have clock, input J, K and next state, input J, K and next state logic Qn plus 1. I need your attention, beta ji. Please observe, everyone please observe very carefully. Now with a clock, how many possibility? Either the clock is low or the clock is high. In case if the clock is low, then in case if the clock is low, irrespective on the input to S and R, it means irrespective to J and K, the next state will remain same as the previous state. Until unless there is no clock, it doesn't matter what input you are going to apply, there is no change in the output. So clock always act as a circuit activator. Now with a high clock, J and K will have 4 possibilities. Either 0, 0 or 0, 1 or 1, 0 or 1, 1. Is it okay? Now please observe what happened if clock is high and J is equals to 1, K is equals to 1. If J is equals to 1 and K is equals to 1, please observe everyone, when J is equals to 1, S is Qn bar. K is equals to 1, it means if S is equals to 0, J is equals to 0, K is equals to 0, 0, 0. J 0, K 0. Let's have a first condition, J 0, K 0. For J 0 and K 0, what we will get? S 0, R 0. So in a SR flip-flop with S 0, R 0, we are getting same as the previous state called hold state. How many of you able to understand up to this part? Please let me know, beta ji. Is it okay? Great. Someone is asking from where you are, sir. Beta ji, I am from north but living in the south. Okay. Great. Now please observe here. For 0, 1, if we talk about 0, 1, then if J is 0 and K is 1, 0 means S is 0, and if K is 1, R is Qn bar. R is Qn. Is it okay? Yes, sir. So if R is Qn, there are 2 possibility of R. See, if we are interested to identify Qn plus 1 at this particular port, is it okay? Yes, sir. We are getting Qn into K. If K is equals to 1, if J is equals to 0 and K is equals to 1, so definitely this will become 0 and this will become Qn. Now we have two possibility of Qn. Qn may be 0, may be 1, means before applying the input J0 K1, there is a possibility of Qn 0 or 1. If we talk about Qn is equals to 0, present in present state, and we are going to apply the present input as 0, 1, then what happened? Sir, if the present state is 0, we are getting 0 here. And for 0, 0, we all can see for 0, 0, SR flip-flop is in a hold state. So it means it will remain 0 only. Is it okay? In case if Qn is equals to 1. If Qn is equals to 1, then what happened? Sir, this will become 0, 1. 0, 1 in a SR flip-flop is a reset state. Then also it is 0. So irrespective of the previous state, if the present input to the JK flip-flop is 0, 1, then next state is 0 only. The next state is 0 only, called reset state. Is it okay? Yes, sir. It is absolutely behaving same as we have observed for the SR flip-flop. However, the delay is increased by 1 AND gate. Is it okay? Yes, sir. But it is behaving like SR flip-flop up to this part. Now let's talk about 1, 0. If S is 1 and R is 0. If S is 1 and R is 0. So now if S is 1 and R is 0. Again, we have two possibility for the previous. Okay. Yes, sir. If S is 0 and R is 1. If J is 1 and R is a 0. If J is 1 and K is 0. If J is 1, if J is 1, if J is 1 and K is 0, if J is 1 and K is 0, if J1 K0, before applying the input J1 K0, there is a possibility of the present state may be 0, may be 1. Let us consider 0. If Qn is 0, then Qn bar will become 1, and what we are getting? S is equals to 1. And for Qn 0, what we are getting here? R is equals to 0. We are getting 1, 0. For 1, 0, what we get? Next state as logic level 1. Another possibility, if we talk about, suppose the present state is logic level 1 and we are going to apply the present input as 0, as 1, 0. So what happened if the present input is 1, 0 and present state is 1? Now please observe, if Qn is 1, Qn bar will be equals to 0. So what we will get? 0. Under this condition, S and R both are 0, 0. So it will remain in the hold state. So it will remain high. So irrespective of the previous state, it may be 0, may be 1. But the present input, if 1, 0, the next state is 1 only, called set. How many of you able to understand? Up to this, it is behaving similar to the SR flip-flop. What is the demerit of SR flip-flop? Invalid state. Demerit of SR flip-flop? Invalid state. So now please observe this JK flip-flop overcome the difficulty of SR flip-flop invalid state. What happens for 1, 1? In case of 1, 1, in a SR flip-flop we get invalid state. Now let's see what happened to JK flip-flop. If we are going to apply 1, 1, if we are going to apply 1, 1, then what happened? Please observe, beta ji. Before applying the input 1, 1, there is a possibility of present state, maybe 0, maybe 1. Let us consider this case that Qn is a 0. Then what happened? If Qn is a 0, then Qn bar is 1, we are getting 1. If Qn is a 0, then we are getting 0. For 1, 0, it will be in the set state. So if green is the present state, then Qn plus 1 will become, for 0, it will become 1. Now again observe, suppose if the present state is this logic level 1, and we are going to apply the input 1, 1, then what happened? If the input is 1, 1 and present state Qn is 1, then we are getting bar of 1, that is 0, 0 multiplied by j, 0 only, and on to the k we are getting 1 into 1. Is it okay? So R is equals to 1. So it means on application of the clock we are getting 1. So what happened? If Qn is 0, we will get 1. If Qn is 1, we will get 0. It indicates with 1, 1, we are getting Qn complement. This state is called as toggle state. It flips the logic. How many of you able to understand? So the demerit, up to this, it is behaving absolutely same as a SR flip-flop. But the last 1, 1, which is invalid for SR flip-flop, now become a toggle state. How many of you able to understand? How many of you able to understand up to this part, beta ji? Is it okay to everyone? Great. Please let me know if there is any doubt. Is it okay to everyone? Great, sir. Hoping all of you able to understand up to this part. Hoping all of you able to understand up to this part. I'm just removing so that, or you can just keep it. For 1, 1, you can just keep it. How many of you able to understand the truth table of JK flip-flop? Great, sir. Is there any doubt up to this part? No, sir. Now let's move towards the characteristic table and excitation table. But before moving towards the characteristic table and excitation table, make a note point. Now what is the note point here? Because of this toggle mode, there is a possibility that if the clock level is high, then output get toggles more than one time in a single clock pulse. That is what we call race around condition. So demerit is race around condition. You can say, sir, disadvantage in level triggered JK flip-flop is race around condition. Now let's talk about race around condition a little bit. Please observe, beta ji. Suppose if we have a JK flip-flop, then with J1 and K1 and a level triggered clock, if we have J1 and K1 and we have a level triggered clock, then output changes more than one time in a single clock pulse. If I talk about time period of the clock is greater than TPDFF, that is propagation delay of the flip-flop. Then with J is equals to 1 and K is equals to 1, output of JK flip-flop changes more than one time in single clock, called race around. So this is what basically we call race around. Is it okay? Theoretically. Now, how to avoid this race around condition? Instead of going with the level triggered, we can go with the edge triggered circuit. In case of a edge triggered circuit, the clock will only appear during the transition of the clock from 0 to 1 or 1 to 0, depending upon the positive or negative edge triggered clock. Another way is a master-slave flip-flop. So race around condition can be avoided by using master-slave flip-flop. One more point. Race around can be avoided by using master-slave flip-flop. We discussed master-slave flip-flop during the registers. Okay. Just before the register, I will discuss about the master-slave flip-flop. Race around condition can be avoided by using master slave flip flop or by using edge triggered clock. Instead of using level triggered, we will prefer edge triggered. Now, how the edge triggering will be represented, that is also very important. Please observe. Up to this part, everything is clear. So only you have to remember one thing for the gate. They are not going to ask must part of from this. What is race around? Race around occurs in JK flip flop. Okay, already they have asked one time by showing the SR flip flop, asked whether the race around condition occur or not. So JK SR flip flop don't have any race around condition. Only JK flip flop, because of the toggling mode, when J1 and K1, we can observe here whenever the input changes, whenever the output changes, the input to the flip flop get changed. And because of the change in the input, whenever the clock appear, output get toggled. Is it okay? So that is why the output changes more than one time in a JK flip flop possible in case if we design a edge triggered clock with a clock pulse greater than the clock pulse width. It will be better to write TPW. Okay, what is TPW here? Please change this. TPW is the pulse width of clock. So pulse width of clock. If the pulse width of the clock is greater than TPDFF, propagation delay of the flip flop, then in a single clock pulse with J1 and K1, JK flip flop output changes more than once. That can be represented as a race around condition, can be avoided by using master slave flip flop, or it can be avoided by using edge triggering. Okay. Now what is edge triggering? Please observe, beta ji. What is edge triggering? Please observe, beta ji. So if we talk about triggering, so triggering is basically if we talk about triggering, so triggering is basically level triggering or edge triggering. Okay. Triggering is basically of two types. First one is your level triggering. What is level triggered? Level triggered means when the level of the clock is high. Clock can be represented by high or low. Is it okay? Yes, sir. So in case of a level triggering, only when the level is high or the level is low, then your circuit will operate. It can be represented into the flip flop by this symbol. Okay. This is what we called positive level triggered circuit, positive level triggered circuit, and negative level triggered circuit. Now please observe here. Positive level triggered circuit or negative level triggered circuit. Here the clock is connected simple. This is your positive level, this is your negative level. Positive level, this is your negative level triggered circuit. If we talk about the second one, that is called as edge triggered circuit, then in case of a edge triggered circuit, we have two possibility. One is called as a positive edge triggered, another one is called as a negative edge triggered. So we have positive edge triggered or we have negative edge triggered. So in a positive edge triggered circuit represented by this symbol, in a positive edge triggered circuit, clock circuit activates only during transition of clock from 0 to 1. So only during transition of clock from 0 to 1. Is it okay? If we talk about negative edge triggered circuit, what does it mean? It can be represented here in this way. So only during transition instant the circuit get activated. It means the clock would appear onto the circuit. However, if we have a negative edge triggered circuit, then negative edge triggered circuit will be represented by this symbol. The clock will be represented with this symbol. The clock will be represented with this symbol. Here, the clock only appear when the level of the circuit changes from high to low. When the level of the circuit changes from high to low. Just opposite to the circuit activate only when transition of clock from 1 to 0. Okay. Only activate during change of clock. I am just writing CLK, that is clock, from 1 to 0. Okay. So now we know about the clock transitions. Okay. We have a level triggered circuit. In a case of a level triggered circuit, the circuit is activated till the level is high. For a positive level triggered circuit, the circuit is activated for a negative level triggered circuit till the level is low. However, in case of a edge triggered circuit, only during the transition period the clock get activated. Can you please let me know by writing in the comment section, Betaji, are you able to understand up to this part? Can you please let me know by writing in the comment section, Betaji, are you able to understand up to this part? Great. Now, please move to the JK flip-flop once again. For a JK flip-flop, we have observed a race round condition. So definitely, a JK flip-flop must need to be designed with a edge triggered. Okay, because when we are going to design it with the edge triggered, the circuit will be comparatively faster than master slave, and race around condition can be avoided. Is it okay? Yes, sir. So we always design the flip-flops in a edge triggered mode, because the edge triggered flip-flops are relatively faster, as well as the JK flip-flop is not suffered with a race around condition. Is it okay? Yes, sir. Now please come back to the JK flip-flop once again. So we are talking about JK flip-flop. We are talking about JK flip-flop. So in a JK flip-flop, if we talk about edge triggered JK flip-flop, then it can be represented by the symbol JK QN complement with this as a clock. This symbol is representing positive edge triggered clock. Is it okay? We know about the truth table. Yes, sir. I am just representing the truth table once more. It's a very important part, so I am just writing once more. Please observe, we have a clock J, K and Qn plus 1. Here I am saying the clock is high. It means there is a transition of the clock from 0 to 1. Whenever there is a transition of the clock from 0 to 1, then only I am saying the clock appear and clock is high. Otherwise, I can say that clock would not appear. So until unless there is no clock, you can say irrespective of the values of J and K, the output of the flip-flop will remain in the previous state, indicating there is no change in the output state. In case if the clock is high, what does it mean? It means there is a transition of the clock from 0 to 1. Whenever there is a transition of the clock from 0 to 1, whenever there is a transition of the clock from 0 to 1, only at that instant clock would appear onto the flip-flop. So you can say JK maybe 0 0, maybe 0 1, 1 0 and 1 1. For a 2 J and K input, we have total 4 possibility. For 0 0, we all have remembered from the past SR as well as JK. For 0 0, we have a hold state. It means in case if input to J and K is 0, 0 and a clock appear, then output will remain hold. Hold means whatever its previous state, the next state remain hold in the same state. In case if clock is high, it means there is a transition from 0 to 1. Then with J0 K1, we are getting 0, that is reset. So hold, reset, set and toggle. So all of you can easily remember SR as well as JK flip-flop truth table. Hold, reset, set, toggle. Set, reset, all of you remember about set, reset. So it is very easy to compare with the SR flip-flop. Is it okay? Now come back to the characteristic table of the JK flip-flop. Characteristic table characterizes the entire behavior of the flip-flop. So for a JK flip-flop, depending upon the input to JK and present state Qn, depending upon present input and present state, we can write next state logic. Yes, sir. So, how many possibility of the present state and present input? How many possibilities of the present state and present input? Sir, we have total 8 possibility. Maybe present input is 0, 0. Present input is 0, 0. Present state may be 0, may be 1. Present input may be 0, 1. Present input may be 0, 1. Present state may be 0, may be 1. Present input 1, 0. Present input 1, 0. Present state may be 0, may be 1. Present input 1, 1. With the present input 1, 1 and present state may be 0, may be 1, we can have all the combination of present input and present state. Now, based upon the present input and present state, we can write next state logic. Yes, sir. In order to fill characteristic table, first just hide this Qn and only observe J and K and observe the truth table. With J and K, what is your truth table suggest for 0, 0? With J0, K0, with J0, K0, truth table suggests that next state is hold state. So with J0, K0, you will get hold state. That is Qn. For these two, reset. For these two, set. And for these two, we get toggle as per the truth table. Is it okay? So it indicates if we have a present input to J0, K0, then next state logic will remain same as the previous state. Next state logic will remain same as in previous state. How many of you able to understand, beta ji? How many of you able to understand, beta ji? Now for present input 0, 1, next state 0, irrespective of previous state, next state will become 0. In the same way, for 1, 0, we get next state as 1, 1. For 1, 1, J1 and K1, next state is Qn complement. Qn complement means for 0 we get 1 and for 1 we get 0. How many of you able to understand? Now we can write the logical expression for Qn plus 1. At the same time, I am just using K map for the minimization of this equation as well. This equation is called as characteristic equation. So in order to write minimized characteristic equation, I am using directly onto the K map. Is it okay? Now please observe, beta ji. We have, if I consider J as a MSB, present input J as a MSB and Qn as a LSB, this is the binary of 0, binary of 1, 2, 3, 4, 5, 6 and 7. We all can see. Yes, sir. So J bar J, K bar Qn bar, K bar Qn, K Qn, K Qn bar. In that way, I have represented so that each subblock represent the min term. Now, where we are getting output logic high onto the binary of 0, 1, 2, 3, 4, 5, 6, 7 numbering. Where we are getting output logic 1, we are getting output logic 1 onto the binary of 1, onto the binary condition of 4, onto the binary condition of 6, and onto the binary condition of 5 as well. So this and this is the essential prime implicant. We must need to make these two pairs, and we have Qn plus 1 characteristic equation as J Qn bar plus K bar Qn. See, this part is asked many times in the previous gate paper. Mostly students do one mistake. They remember J Qn bar as S and they remember R as K Qn. So there is a possibility of mistake. This is a characteristic equation. When we designed JK flip-flop by using SR flip-flop, then we have S is equals to J Qn bar and K is equals to R Qn. But when we talk about next state characteristic equation is J Qn bar plus K bar Qn. So always remember this, okay? Hoping up to this part everything is clear. From the characteristic table, we can write excitation table as well. Excitation table is the table which indicates excitation needed in order to get desired next state from the available present state. So, present state Qn, next desired state Qn plus 1. Based on that, we can find the excitation needed onto the J and K. Is it okay? In a JK flip-flop. Great. Now, please observe how many possibility of present state and next desired state. Maybe present state is 0, next desired state is also 0. Present state 0, next desired state 1. Present state 1, next desired state 0. Present state 1, next desired state 1. Hoping all of you able to understand this. Please let me know by writing in the comment section, beta ji. So now please observe here. What happens for 0, 0? What happens for 0, 0? If the present state is 0 and next desired state is also 0. If the present state is 0 and next desired state is also 0. Characteristic equation suggests everything. Is it okay? So if you observe Qn and Qn plus 1, present state 0, next desired state 0. There is only two positions where present state is 0, next desired state is 0. What is the input to J? Input to J needed must be 0. However, input to K may be 0, may be 1. So anything can be at the input to K. But the input to J must be 0. Is it okay? Can you please let me know by writing in the comment section, beta ji? Great. Same for 0, 1. 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 J must be 1. However, K may be 0, may be 1. You can indicate in the same way. So J must be 1, K may be 0, may be 1. Now let's talk about 1, 0. If you observe 1, 0, if you observe 1, 0, 1, 0, 1, 0, then for 1, 0, J may be 0, may be 1, J may be 0, may be 1, but K must be, J may be 0, may be 1, but K must be 1. K must be 1. J may be 0, may be 1, but K must be 1. Now come to the last 1, 1. If you observe 1, 1, What happened, bhai? Oh, something happened with the board. I need just a minute to restart the board, Betaji, because some issue happened. So allow me for a wait of just 2 minutes. Just a second. Wait for just 1 minute, Betaji. I'm just restarting everything. Extremely sorry for the delay. Extremely sorry for the delay. Just wait for another 1 minute. Wait for 1 minute, Betaji. Just a minute. Returning back very soon. Extremely sorry for the delay. Just a minute. I'm returning very soon, Betaji. Just a minute. Unfortunately, we lost whatever I have mentioned before, but no issue. I am writing quite fast, so we will retrieve the part up to which we have completed. Okay. So I am on the characteristic table. Onto the characteristic table. We have completed characteristic table and excitation table. Okay. Okay. Yes, sir. Based upon J, K, Qn, we can comment on to Qn plus 1. Possibility 0, 0, 0, 1, 0, 0, 0, 1, 0, 1, 1, 0, 1, 0, 1, 1, 1, 1. We have present state possible, maybe 0, maybe 1, maybe 0, maybe 1, maybe 0, maybe 1, maybe 0, maybe 1. And this is the binary of 0, 1, 2, 3, 4, 5, 6, and 7. For these two, we have Qn. For these two, we are getting 0, reset, 1, and Qn complement. Because this is required for the upcoming portion. Na? So just I am mentioning from here only. Rest part is already I have completed. Okay. Yes, sir. So we will get 0, 1. We will get 0. We will get. Sometimes machines are not as faster as the humans, huh? Okay. That's not true. Anyhow, it is not true. Machines are always faster than a human. 0, 0, 1, 1. 1 0. Now please observe here we have Qn plus 1. Already I have completed this characteristic equation J bar J K bar Qn bar K bar Qn K Qn K Qn bar, and we have the binary of 0 1 2 3 4 5 6 and 7, where we are getting logic level as onto the 1 5 6 and 4. So we have this pair and this pair possible as per the min terms. Qn plus 1 logical expression will become jqn plus k bar qn. Hoping up to this part all of you able to recall. Great. Now please observe the excitation table. Excitation table. In excitation table, based upon the present input and present state, we can comment based upon the present state and next desired state, we can comment onto the excitation needed on J and K. So present state 0, present state 0, next desired state 0, present state 0, next desired state 1, present state 1, next desired state 0, present state 1, next desired state 1. Is it okay? Now please observe how to fill the excitation table. For 0 0, if you observe 0 0, what is the value of J beta G? What is the value of J? What is the value of J and what is the value of K? So J must be 0, K may be 0, may be 1. If we want present state 0 and next desired state also 0. If we want present state 1, 0, next desired state 1. Present state 0, next desired state 1. So J must be 1. However, K may be 0, may be 1. So we represent it as don't care. Up to this part I have completed. And 1 0, if we talk about 1 0, if we talk about 1 0, then for 1 0, J may be 0, may be 1, but K must be 1. J may be 0, may be 1, but K must be 1. Up to this part already I have completed. Now observe for 1 1. Now observe for 1 1. For 1 1. For 1 1, if you observe for 1 1, then J may be 0, may be 1, but K must be 0. In the same way, you have to mention in your note as well. Now, characteristic table, it means truth table guides characteristic table and characteristic table guides excitation table. Is it okay? Can you please let me know by writing in the comment section, beta ji? Great, sir. It is very easy to remember. See, 0 1, first 2 is 0 1 for the Qn plus 1. Just write plus first 2 0 1 for the J. Then don't care, don't care, don't care, don't care, and just reverse this. Just reverse this for the K. So now you are always going to remember excitation needed on J and K in order to get next desired state from the available present state. How many of you able to understand? Now please tell me. Up to this part everything is clear? Great, sir. Up to this part everything is clear? If you have any doubt, please let me know by writing in the comment section, beta ji. Okay, great. Also, in a JK flip-flop, because this is needed for T and D as well, so let me write down for the JK flip-flop. If we talk about JK flip-flop, I have represented like this. Hoping all of you have noted this. Because it is needed and the board get restarted, so I need to write it once again. How many of you have remembered about the H triggered? Great. And the truth table of the JK flip-flop, based upon the clock JK, we have Qn plus 1. When the clock is 0, then irrespective of J and K, output will remain same. If the clock is high, then with the high clock we are getting hold, reset, set and toggle. Hoping all of you are able to recall this. Great. Yes, sir. Now come back. Up to this part already I have covered about the JK flip-flop, characteristic table and excitation table. Let's move towards D flip-flop. Okay. Next write down D flip-flop. Next write down D flip-flop. Now please observe beta ji. D flip-flop. D flip-flop is also called as a delay flip-flop. D flip-flop is also called as a delay flip-flop. And why it is called as delay flip-flop? Because it will give the output same as the input, but after a propagation delay of the flip-flop. Is it okay? That is why it is called as delay flip-flop. Now please observe, we have a D input and it can be designed by either using JK flip-flop or by using SR flip-flop. So please observe, in case if the D flip-flop is designed with a JK flip-flop, if D flip-flop is designed with the JK flip-flop, if D flip-flop is designed with the SR or a JK flip-flop, please observe beta ji. First I am representing by using D flip-flop by using SR flip-flop. So D flip-flop by using SR flip-flop, we all can see S is equals to D and R is equals to D bar. We can also design JK flip-flop, we can also design SR D flip-flop by using JK flip-flop. So please observe beta ji, D flip-flop by using JK flip-flop. Here it can be clearly observed J is equals to D and K is equals to D bar. So D flip-flop can either be designed by using SR flip-flop or it can be designed by using JK flip-flop. In a D flip-flop, there is only one input and two output states, that is Qn and Qn bar. We will observe the next state onto the Qn port as Qn plus 1 and onto the Qn bar port as Qn plus 1 whole complement. Is it okay? Yes, sir. In order to understand D flip-flop, we can construct. In order to understand D flip-flop, we can construct its truth table. Yes, sir. So, please observe D flip-flop truth table. Clock input D Qn plus 1 as the next state which we are observing at Qn port only. So we are observing at this port as Qn plus 1 or this port as at Qn plus 1. Qn plus 1 means next state. Present state is Qn. Qn plus 1 is the state on application of the clock and the input we get. Now please observe beta ji, in order to fill this, I am using truth table of the JK flip-flop. Okay. If you know about JK, you remember SR as well. Only the 1-1 condition will give invalid, the last. Otherwise, rest of the things will remain same. So for this, I am following the truth table of the JK flip-flop. What happens if J is equals to 0 and K is equals to 0? We get hold. Okay. What happened if J is equals to 0 and K is equals to 1? We get reset. Now please observe here. J is D and K is D bar. Then the flip-flop is called D flip-flop. Haji beta, you can ask. You can ask beta, please feel free to ask. There is no issue. You can ask your doubt beta ji. Now please observe here. J is equals to D and K is equals to D bar. Now please observe, in case if the clock is not in transition from 0 to 1 in a positive edge triggered circuit, then irrespective the input applied to J and K, if the clock is not in transition, irrespective of the input applied to J and K, the output will remain in the previous state only. So output will remain in the previous state only. We can say until unless there is no clock, there is no change in the output data of the flip-flop. Is it okay? So it can be, I can rearrange my statement as clock act as a flip-flop activator. Until unless there is no clock, it doesn't matter what input you are going to apply, there is no change in the output. Is it okay? Yes, sir. We all know about this symbol. This is a symbol of positive S triggered. So a positive S triggered circuit means whenever the clock will have a transition from 0 to 1. Suppose if the clock is high, if the clock is high means the clock is in transition from 0 to 1. Then only during the transition of the clock, if D is equals to 0, then it means J is equals to 0 and K is equals to 1. J0, K1 we get reset. J0, K1 we get reset. So if we apply 0, we get next state Qn plus 1 as a 0 only. If we apply 1, then J1, K0. J1, K0. If D is equals to 1, J1, K0. JK flip-flop, 1, 0 will give you 1. Set state. So it indicates the next state is same as the input we are giving. And that is why it is just a delay flip-flop. Output and inputs are same. But the output get delayed by the propagation delay of the flip-flop. Is it okay? So defined as D flip-flop. How many of you able to understand? If we will write the characteristic equation, then Qn plus 1 is the same as D, also called as transparent latch. How many of you able to understand? Please let me know, beta ji, if you are able to understand up to this part. Haan ji beta, you can please ask whatever you want to ask. Huh? This is a crash course. No, it's not a crash course. It's a kind of full course, but with a rapid speed. So you are going to get everything of this course, but the course is a little bit faster. Okay. Why I'm saying this, everything is there in the course because of the limited time, but I just want to complete the entire things that is required for your GATE 2027. Okay, so that is why I'm moving little bit faster. You can have your notes. You can pause the lectures wherever you want and you can make your notes. Is it okay? Or you can just download the notes directly. You have to understand here in a better way. If I go very slow now, it will be difficult for you to get all the things covered in this particular series. Is it okay? Sir, I watched the video of this recorded course. Your teaching style is thank you, beta ji. Looking forward to study more subjects. Thank you, beta ji. Okay. So, if you just observe now, from the starting of the class that started at 9 o'clock, now it is 10 o'clock. I have only discussed about one thing, truth table of JK flip-flop. Is it okay? So that is the all thing that we have able to learn so far. But not only that, we also understand how to construct characteristic table, how to write excitation table. We have seen about the edge triggering, level triggering, race around condition. So there are many small parts in this. Is it okay? All associated with the JK. Now please observe the D flip-flop and T flip-flop so that you can design any new flip-flop. Please observe here. Hoping all of you able to understand the D flip-flop truth table. Now, can you construct the characteristic table? Yes, sir. Let's discuss about characteristic table of D flip-flop. So if we talk about characteristic table characterizes the entire behavior of the flip-flop. Characteristic table based upon the characteristic table based upon the present input and present state, we can write the logic of next state. Yes, sir. So how many possibility of present input and present state? We have a present input D and present state Qn. How many possibility, beta ji? Present input may be 0, present state may be 0, present input may be 0, present state may be 1, present input may be 1, present state may be 0, present input may be 1, present state may be 1. Is it okay? Yes, sir. Now, to fill this, we can follow the truth table. Since we all can observe a D flip-flop is a transparent latch. So it means you will get Qn plus 1 same as D. So whatever D we have, the same is going to be onto the Qn plus 1. Yes, sir. So 0, 0, 0, 1, 1. How many of you able to understand? You can observe from here as well. For present state, for D0, we will get 0, and for D1, we will get 1. So I am using truth table to hide this Qn and observe what Qn plus 1 will be. Just we have to copy paste this D. Now, can you write the excitation table? Yes, sir. What is the characteristic equation? Qn plus 1 is equals to D. Now, please observe, beta ji, excitation table. Excitation table. If we talk about excitation table of D flip-flop, then excitation table is the table which gives the information of excitation needed in order to get desired next state from the present state. So present state may be 0 or maybe 1. Present state may be 0, maybe 1. Present state 0, next desired state may be 0, maybe 1. Present state 1, next desired state may be 0, maybe 1. Now, since D flip-flop is a transparent latch, so whatever you want at Qn plus 1, just you need to put the same onto the D. Is it okay? Yes, sir. It is very easy to go with a D flip-flop. In a D flip-flop, we are getting same next state, whatever input we are applying. So D flip-flop is a, thank you, beta ji. D flip-flop is a transparent latch. Hoping all of you able to understand. Great, great. Now please observe, up to this part, I am hoping D flip-flop is clear to everyone. The last flip-flop, and then we are going to move to design one flip-flop. Whatever flip-flop you will tell me, na, that I am going to design. So today you are going to be the inventor of one new flip-flop. Be ready to invent one new flip-flop, okay? Now please observe. The last one is your T flip-flop. Let me complete T flip-flop, and then I am going to make you an inventor of a new flip-flop, okay? So let's have a last flip-flop, that is T flip-flop. So T flip-flop, also called as toggle flip-flop, also called as toggle flip-flop. T flip-flop can be designed by using JK flip-flop. T flip-flop can be designed by using JK flip-flop. T flip-flop can be designed by using JK flip-flop, where the T is equals to, J is equals to T and K is equals to T. Very simple. So T flip-flop can be designed by using JK flip-flop. J is equals to T, K is equals to T. J is equals to T and K is equals to T. Now, we can construct truth table of the T flip-flop. So truth table of T flip-flop, we have clock T Qn plus 1. How many possibility of T? Only two possibilities, 0 or 1. But that possibility will only come when there is a transition of the clock. Since it's a positive as triggered, so whenever the clock changes its level from 0 to 1, only at that time the circuit get activated, and based upon the input, output will be changed. So if the clock is 0, it means there is no transition of the clock. Until unless there is no transition of the clock, doesn't matter what is the input to J and K, output will remain in the previous state only. However, if there is a transition of the clock from 0 to 1, it means I am representing clock, it means there is a transition of clock from 0 to 1. Then based upon the input to T, if T is 0, it means J is 0, K is 0. And we all know in a JK flip-flop, if J is equals to 0 and K is equals to 0, then your next state will remain in hold state. So next state will remain in hold state. Is it okay? Now if we put T is equals to 1, it indicates J1, K1. And in a JK flip-flop, if J1, K1 and a clock is applied, next state will become toggle mode. So it means in a T flip-flop with T is equals to 1, J is equals to 1, K is equals to 1, and T flip-flop will operate in a toggle mode. How many of you able to understand, beta ji? Great. So it is very easy to remember the truth tables of all flip-flop. We have SR, QN, 0, 1, invalid. We have JK, QN, 0, 1. That is for 0, 0, for 0, 1, for 1, 0, for 1, 1. QN, 0, 1, QN bar. For D flip-flop, transparent latch, whatever input, same we are getting on to the next state. And T flip-flop, either it will operate in hold or it will operate in toggle. If T is 0, it means J and K both are 0, 0. So we have hold. If T is 1, it means J and K both are 1, 1. It means it is in toggle mode. So it will either operate in hold or operate in toggle mode. Now let's talk about characteristic table. Characteristic table of T flip-flop. So in a T flip-flop, based upon the present input T and present state Qn, we can comment on to the next state Qn plus 1. So maybe present input T is 0 or T is 1. Present input 0, present state may be 0, may be 1. Present input 1, present state may be 0, may be 1. Is it okay? Yes, sir. Now, please observe, beta ji. In case if T is 0, what happened? T is 0 means hold. T is 1 means toggle. So T0 means hold. T1 means toggle. Toggle means if Qn is 0, its complement is 1. If Qn is 1, its complement is 0. We all can see the logical expression of Qn plus 1 in terms of T and Qn. The truth table is same as the XOR gate truth table. So you can easily say that Qn plus 1 is equals to T XOR Qn. How many of you able to understand, beta ji? Please let me know by writing in the comment section. Let me arrange like this. Is it okay now? Great. Can you construct the excitation table from the characteristic table? Yes, sir. So let's try to write down the excitation table also. Excitation table. Sir, in a T flip-flop, excitation needed onto the T flip-flop in order to get desired next state Qn plus 1 from present state Qn. Okay. Yes, sir. How many possibility with Qn and Qn plus 1? 4 possibility. Either both are low, any one of them is high, or both are high. Is it okay? It means your present state may be 0, next state may be 0. Present state 0, next desired state 1. Present state 1, next desired state 0. Present state 1, next desired state 1. Now for T, we all can see, if you observe characteristic, then for present state 0, next desired state 0, t need to be 0. Definitely, if there is no change in the state, t need to be hold, operate in a hold mode. So if there is a change, t will be in the toggle. If there is same, t is in a hold mode. How many of you able to understand, beta ji? Let me summarize all the flip-flop. Okay, so if I summarized all the flip-flop, please observe, beta ji. We can observe this one point, and that will help you to solve or to memorize all of the flip-flop truth table. You have to just remember about the JK flip-flop. So JK QN plus 1. All of you remember about the JK flip-flop? Yes, sir. 0, 0, 0, 1, 1, 0 and 1, 1. We all remember about the truth table of JK flip-flop, sir. In a JK flip-flop, for 0, 0 with a clock applied, we get QN, that is hold, 0, reset, set or toggle. For SR flip-flop, you can replace this J by S, K by R and this QN with a don't care. Is it okay? Now it will become SR flip-flop. If we talk about D flip-flop, then very easy. J is D and K is D bar. J is D and K is D bar. So if you observe this one, it gives the information of D flip-flop truth table. So if you apply 0, you will get 0. If you apply 1, you will get 1. And also you know about the construction. J is D and K is D bar. Hoping all of you able to understand. Similarly, if you observe the first and last, you can see T flip-flop truth table as well. And construction of the T flip-flop. In T flip-flop, J and K both are T. If 0, it will operate in a hold mode. If 1, it will operate in a toggle mode. So now with this one shortcut, you are going to remember the truth table of all available flip-flops. Is it okay? Yes, sir. Up to this part, everything is clear. Let's have the excitation table also. I just wanted to have a summary of excitation table also, because excitation table is very important table. Excitation table is very important table. Okay. So I am just mentioning one excitation table of all the flip-flops. You can just watch this page, or you can just note down as a short note. Whenever you are going to solve any question based upon the flip-flop, only these 2 pages will be sufficient to solve any question. Is it okay? And one line is, before applying clock pulse, first find input to the flip-flop, apply the clock pulse and follow the truth table. That is all you have to do. Any question based on the sequential circuit can be solved. Now please observe excitation table. Excitation table, sir, if we compare all the excitation tables, we have based upon the present state and next desired state, we have S, R, J, K, S, R, J, K and D and T. Okay. So let me arrange all the flip-flops excitation table on one page. Okay. Yes, sir. Very easy to remember. Please observe here. By today only, you are going to remember forever. Please observe. 0, 0. How many possibility? Present state, next state. Present state 0, next state 1. Present state 1, next state 0. Present state 1, next state 1. So based upon present state and next desired state, we have 4 combination. Either present state is 0, next state may be 0, maybe 1. Present state 1, next state may be 0, maybe 1. So we have total 4 possibility. Now for S, you have to copy this Qn plus 1 first 3 states and then make don't care. It is very easy to remember. Yes, sir. Now just reverse this. Just reverse this to have R. So when I reverse, this 0 will come here, this 1 will come here, this 0 will come here, and this don't care will come here. That's all. Now we have an excitation table of the SR flip-flop. Come back to the JK. For JK is superior. So for JK, only paste these two for J. Okay, then other make don't care. If you remember J, then you are not going to have any issue to remember K as well. Just reverse J. So how to reverse J? This 0 here, this 1 here, this don't care here, and this don't care here. D flip-flop is a transparent latch. D flip-flop is a transparent latch, sir. Transparent latch means Qn plus 1 is the same as D. So just copy this and paste here. So just copy this and paste here. That is 0, 1, 0, 1. What about T flip-flop? T flip-flop. Sir, very easy to remember T flip-flop. If we have 0 and we want 0. So for same, it need to be on hold state. If T is 0, it is in hold state. If different, it need to be toggle. For same, it need to be on hold state. Or you can just paste the XOR. How many of you able to understand? So this is the summary of all we have studied so far. Very important, these 2 pages can help you to solve any question. Yes, beta ji. Beta ji, whatever I am just telling you now, if after that you will solve the PYQ question, just keep one, I have already told you, keep one solution book with you. Go with the PYQ, you will be easily able to understand everything. Okay. And yes, if you remember the truth table and excitation table, you can solve any question. It doesn't matter whether you have studied counter or not, register or not. Just you have to remember one thing. Before applying clock pulse, first find input to all flip-flops. Then apply clock pulse and follow the truth table. Entire sequential circuit is within this one line. Is it okay? Great. Now, please come to the designing of some new flip-flop. Are you ready to design or invent some new flip-flop? Are you ready to design some new flip-flop, beta ji? Are you ready to design some new flip-flop? Steps for designing of steps for designing of desired flip-flop from the available flip-flop. Please write down steps for designing of desired flip-flop from the available flip-flop. Steps for designing of desired flip-flop from available flip-flop. Are you ready, beta ji, to invent any new flip-flop? Okay, so if you are ready to invent any new flip-flop, just write down these 4 steps. Okay, now please observe what is step 1. Step 1, write the characteristic equation of the required flip-flop. Whatever flip-flop is required, you need to write the characteristic equation of that flip-flop first. Is it okay? Yes, sir. Next, write the excitation table of available flip-flop. Write the excitation table of available flip-flop from characteristic table of required flip-flop. From characteristic table of required flip-flop. Write excitation table of available flip-flop from characteristic table of required flip-flop. Then write excitation equation and minimize it. Write excitation equation and minimize it. Then implement the logic circuit. Implement the logic circuit. That's all you have to do. So how to design any desired flip-flop from the available flip-flop. Tomorrow we are going to discuss questions. Okay, lots of questions based on the sequential circuits. Okay, so please observe here. Write the excitation equation and minimize it. Implement the logic circuit. How many of you able to understand up to this part? Let's try to design one new flip-flop. Whatever you want, just let me know. I will design the same. Okay. Yes, sir. So just you have to give me, you can just have a whatever you want to design, you can just have to put it in the comment section. Okay. Design XY flip-flop by using D flip-flop. Design XY flip-flop whose truth table is okay. Design XY flip-flop as per truth table shown below by using D flip-flop. Are you ready to design your desired flip-flop, beta ji? Please let me know by writing in the comment section. Okay. Are you ready to design your desired flip-flop? Yes, sir. We have two input X and Y. So whatever next state you want, just mention in the comment section. We have X and Y. How many possibility of X and Y? 4 possibilities, sir. What you want as a next state in a XY flip-flop? Now you are the inventor of some new flip-flop called XY flip-flop, and you want to design this flip-flop by using D flip-flop. Is it okay? Is it okay, beta ji? Please let me know by writing in the comment section. Or let it be a JK flip-flop. It will be a better to go with the JK flip-flop. Let's try to go with the JK flip-flop. I'm changing this question. Okay, we want to design a XY flip-flop as per the truth table shown below by using JK flip-flop. Please do comment and let me know what next state you want. If we give input 0, 0, whether you want a input as 0, 1, QN, QN complement, whatever input you want, just let me know by writing in the comment section. For 0, 0, what next state you want? For 0, 1, what next state you want? For 1, 0, what next state you want? For 1, 1, what next state you want? Just mention in the comment section. I'm waiting for your answer, beta ji. Just let me know what you want to design. I'm giving an opportunity to you to become one designer of your desired flip-flop. Designer of desired flip-flop. Let me know your desire. In the comment section, just let me know what you want. For 0, 0, what next state you want? For 0, 1, what next state you want? Let me know directly in the comment section, beta ji. Whatever you want, just let me know. 0, 1, QN bar, QN, anything. No one is writing anything in the comment section, huh? For 0, 0. For 0, 0. Okay, let me take as QN complement. Okay. For 0, 1. You want to design a new kind of flip-flop by using JK flip-flop, just like T and D flip-flop. And you want an XY flip-flop. If the input is a 0, 0, next state will become QN complement. If the input is a 0, 1, because none of you have mentioned, if you want, you can just mention in the comment section, beta ji. I'm waiting for you. I'm waiting for you. Okay. So if I'm for the present state 0, 1, for the present state 0, 1, what next state you want? Let us suppose you want QN. For this you want 1. For this you want 0. Whatever you want, just you can tell me. So this is your desired flip-flop. we are going to invent a new flip-flop. Okay. And that flip-flop will give the output as indicated in the truth table given below. Okay. Yes, sir. And we want it to design by JK flip-flop, just like we designed a T flip-flop or a D flip-flop. Okay. Yes, sir. So let us discuss about X, Y and Qn plus 1. If you want, you can change it. Whatever you want, you can fill, like 0, Qn bar, Qn 1, anything. Whatever you want, you can design that particular flip-flop. Now, please observe how to design. We are going to follow these 4 steps. The first step is to write characteristic equation of the required flip-flop. And all of you know how to write characteristic table of the required flip-flop? Yes, sir. All of you know how to write the characteristic table of the required flip-flop. This XY is the required flip-flop. And available flip-flop is JK flip-flop. So first of all, you have to write the characteristic table of the required flip-flop. So characteristic table of the required flip-flop. We have X, Y. Characteristic table, just I am writing CR table of required flip-flop. So first write characteristic table of required flip-flop. Required flip-flop is, sir, required flip-flop is XY and the present state is Qn. Next state Qn plus 1. So first write characteristic table of the required flip-flop. Maybe the present input to X and Y is 0, 0. Maybe the present input to X and Y is 0, 0. Present state may be 0, may be 1. Present input to XY may be 0, 1. Is it okay? Yes, sir. Present state may be 0, may be 1. Present input to XY 1, 0. X1, Y0. Present input may be 0, may be 1. Present input X1, Y1. Present state may be 0, may be 1. How many of you able to understand up to this part? Please let me know by writing in the comment section, beta ji. First of all, you have to write the characteristic table of the required flip-flop. In order to fill this table, we have to follow the truth table. What we want to design? We want to design a flip-flop which gives for a input 0, 0, next state Qn complement. For a input 0, 0, next state Qn complement. So how to fill here? Sir, next state Qn complement. So for 0, 0, next state Qn complement. If Qn is 1, Qn plus 1 will become 1. Why? Because Qn complement. Next state is Qn complement. Next state is Qn complement. What do you want for 0, 1? Qn. For 0, 1 you want next state as Qn. For 0, 1 you want next state as Qn. So 0, 1. Is it okay? Yes, sir. Now for 1, 0 you want 1. For 1, 0 you want next state as logic level 1 irrespective of the present state. And for 1, 1, for x1, y1 you want next state to be 0. So irrespective of the previous state you want 0. All of you able to understand how to fill the characteristic table now? Great. Once you have characteristic table, next step is to write excitation table from the characteristic table. Now write excitation table of available flip-flop. Excitation table of available flip-flop. So excitation table of available flip-flop. We want to design this XY flip-flop by JK flip-flop. So available flip-flop is JK flip-flop. We need to write the excitation table of the JK flip-flop. We need to write excitation table of the JK flip-flop. Please observe, beta ji. Yes, sir. Now, for excitation table of JK flip-flop, all of you remember about the excitation table of JK flip-flop? Yes, sir. I am just writing here in the rough part. Please observe. Excitation table of the JK flip-flop. I am writing here as a rough part. Please observe, beta ji. Based upon Qn and Qn plus 1, we have JK. So 0, 0, 0, 1, 1, 0, 1, 1. Hoping all of you have remember 0, 1, don't care, don't care. 0, 1, don't care, don't care. Okay? Yes, sir. Now please observe. From the characteristic table of the required flip-flop, we have to construct excitation table of available flip-flop. So we have first completed characteristic table of required flip-flop. Now the result of characteristic table of required flip-flop, I am going to use to write excitation table. Now please observe, for 0, 1, present state 0, next state 1. Present state 0, next state 1, excitation needed on J is 1 and on K is, excitation needed on J is 1 and on K is don't care. In the same way for 1, 0, for 1, 0, we need don't care 1. For 0, 0, for 0, 0, we need 0, don't care. How many of you able to understand, beta ji? For 1, 1, for 1, 1, we need don't care 1, don't care 0. For 0, 1, 1, don't care. How many of you able to see this? 1, 1, 1, 1 will have don't care 0. 0, 0, 0, 0 will have 0, don't care. And for 1, 0, for 1, 0, we have don't care 1. Is there any doubt up to this part? Please let me know by writing the comment section, beta ji. Step 1 is to write characteristic table of required flip-flop. Step 2 is to write excitation table of available flip-flop from characteristic table of required flip-flop. Next is to write the logical expression. See, we want to design a XY flip-flop from JK flip-flop. So what are the inputs available onto the JK flip-flop? X, Y and Qn. In terms of X, Y and Qn. In terms of X, Y and Qn, with X as a MSB and Qn as a LSB, 0, 0, 0 is the binary of 0. In the same way, this X as a MSB and Y Qn as a LSB, 0, 0, 1 is the binary of 1. In the same way, binary of 2, 3, 4, 5, 6 and 7. Can I represent like this? Yes, sir. With X as a MSB and Qn present state, either we can give present input or we can give present state to the available flip-flop in order to get desired next state. Is it okay? Yes, sir. Now please observe. Now please observe, beta ji. Next is to write the logical expression of J and K. So where we are getting J high, 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 J we are getting high onto the binary conditions of, onto the binary conditions of 0 and 4, 0, 4. Here the don't cares are also very important and logic zeros are also very important. Two logic zeros, 2 and 6. 2 and 6 are logic 0. 2 and 6 are logic 0. So 2 and 6 are logic 0 and there is only two positions where we are getting logic 1, 4 and 0 and 4. So 0, 4. Don't care we are getting onto the 3, 5, 6 and 7. 6 and 2. 6 and 2. 6 and 2. So 1, 3, 5. 1, 3, 5, 7. Can we find the minimized expression for the logical expression required onto the J? Yes, sir. We are going to apply onto the available JK flip-flop either the present input X, Y or present state. So in terms of present input and present state, we have these numberings, X as a MSB and Qn as a LSB. So Y bar Qn, Y Qn, Y Qn complement. Okay, numbering 0, 1, 2, 3, 4, 5, 6 and 7. I need this K map once again for K as well. So just copying this. Okay. Now please observe for K as well, where we are getting logic 1 on K. Onto the K, we are getting logic 1 in a binary condition of 1 and in a binary condition of 7. 1 and 7. 1 and 7. And don't cares are don't cares are 0, 2, 4, 6. 0, 2, 4, 6. 0, 2, 4, 6. Is it okay? 0, 2, 4, 6 are the don't cares. Yes, sir. Now please observe, beta ji. We are getting 0, 1, 4, 1. 1, 5, 3, 7 as a don't care. So here we have only one chord possible, and with this chord we are getting j equals to y bar. J equals to y bar. And what is k, beta ji? Please observe what is k, beta ji. If we talk about k, then we have 1 and 7. 0 is don't care, 2 is don't care, 4 is don't care, and 6 is don't care. 3 and 5s are zeros. So we have only possibility of the two pairs. With these two pairs, k will be equals to x bar y bar plus of x bar y, xy. That is x XNOR y. How many of you able to understand, beta ji? X bar y bar plus of xy x XNOR y. Next is your circuit implementation. So please observe the circuit implementation. We want to design a XY flip-flop, but the available flip-flop is JK flip-flop. So JK QN complement. And sir, it's a positive or a negative S triggered. So I'm using positive S triggered first. Okay. Yes, sir. Now we want to design a XY flip-flop. For a XY flip-flop, what is J? J is equals to Y bar. So J is equals to Y bar. J is equals to Y bar. And what is K? K we are getting, sir, X XNOR Y. Is it okay? X XNOR Y. X XNOR Y means we need one XNOR gate. Okay? Yes, sir. And X XNOR Y. How many of you XNOR? Let me represent a XNOR, beta ji. X XNOR Y. So this is what we want to design. Basically, your desired logic gate is this. Just like T or D flip-flop, you have designed a new flip-flop called XY flip-flop. Is it okay? 0426. What is 0426, beta ji? 0426. Beta, see, we will not take this chord. We will not take this chord. Why? Because all are don't care. Don't care gives us support to get minimized expression. If we take the chord, then it will increase by one more expression. It increases the number of logic gates. So don't care, already in the K map solving, I told you, don't care maybe logic 0 or 1, depending upon our requirement, and our prime requirement in K map is to get minimized expression. So we always select the logic of don't care such that it helps in minimizing the logical expression. And in the same K map, we can select some of the don't cares as logic 1 and some of the don't cares as logic 0. All these things already I have discussed. Sir, class timing, I am new. Beta ji, for all those students who have just joined, you can just subscribe this channel, okay, and you can identify all the previous lectures are already in the playlist, and they are available in the live section. When you just open the channel, you will get home, videos, and then live, shorts, and so on. So you can just go with the live one. In the live one, if you scroll down, you will get all the classes, because Monday to Friday, 5 days these classes are going on. Is it okay? And the timings are 9 to 11 only. Okay? Great. So now the point comes, what kind of question gate may Gate already designed a question like this. Given a XY flip-flop, they can fill as per their desire and ask you find the logical expression for J or K, or which of the following is the implementation by using XY flip-flop or implementation by using JK flip-flop. They will not design this circuit. Instead of giving this circuit, they will give this expressions in the options. Is it okay? Otherwise, they may give you this circuit and ask you to find out the truth table, or they may give you this circuit and ask you what is the output after third or fourth clock, and they will give the value of X and Y. Is it okay? So this kind of questions will be there. How to solve? In order to understand if the circuit is given and we have to identify the truth table, then we can go with a simple thumb rule, Varun sir thumb rule. Before applying clock pulse, first find input to the flip-flop, then apply clock pulse and follow the truth table. You know about JK flip-flop? Have you remembered the JK flip-flop truth table? Yes, sir. If you remembered the JK flip-flop truth table, then we can check this circuit. Let's verify whether we have created the correct circuit or not. So we have a input X, Y, clock, and Qn plus 1. Okay, yes sir. Now please observe, in terms of XY, how many possibility? In terms of XY, how many possibility? Sir, total 4 possibility. In terms of XY, how many possibility? Total 4 possibility. Either X0, Y0, X0, Y1, X1, Y0 or X1, Y1. Now please observe, what happened if X is 0 and Y is 0? In order to understand, we have to follow thumb rule. Thumb rule suggests to solve any sequential circuit, first of all, identify inputs to the flip-flop before applying clock pulse, and then apply the clock pulse and follow the truth table. So please observe here. Please observe here. We have a truth table of JK flip-flop. We all remember about the truth table of JK flip-flop. Okay. Yes, sir. 0, 0, 0, 1, 1, 0 and 1, 1. I'm just using a rough part to make you understand. JK flip-flop will have a truth table Qn 0, 1, Qn complement when the clock is appeared. Yes, sir. So now please observe what happened in case if we have X0 and Y0. If we have X0, X0 and Y0, X0 and Y0, first find input to the flip-flop before applying clock pulse. So I'm not going to apply any clock pulse unless there is no clock. The output will not change irrespective whatever inputs are coming. Now first find input. So if Y is 0, its complement is 1. Yes, sir. And this is a XNOR gate. XNOR gate is a equivalence gate. It gives the output logic 1 whenever the two inputs are same. Onto the JK flip-flop, if both the inputs are 1, 1, next state will become toggle. So with the X is equals to 0, Y is equals to 0, we get next state as a toggle state. Is it okay? How many of you able to understand, Betaji? Great, sir. Again observe. Suppose if the present state is a 0 and next is if the present input to X is 0 and Y is 1. X is 0, Y is 1. If this is 1, its complement is 0. 1, 0 different, so this will give 0. 0, 0 on the JK flip-flop will give next state as. First find input to the flip-flop. So I am finding the input to the JK flip-flop first. Forget about these logic gates. You have to find out the inputs to the flip-flop. So this is the input to the flip-flop. Then apply the clock pulse and follow the truth table. That is all you have to do for solving any question based on the sequential. There is only one thumb rule. It doesn't matter whether you have studied counter or not, registers or not, finite state machines or not. Everywhere you have to do one thing. Before applying clock pulse, first find input to the flip-flop, then apply clock pulse and follow the truth table. That's all you have to do. Again observe for 1, 0. What happened for X is equals to 1 and Y is equals to 0? X is equals to 1 and Y is equals to 0. Let's have a discussion on X is equals to 1 and Y is equals to 0. Before applying clock pulse, first find input to the flip-flop. X is equals to 1, Y is equals to 0. So what is the input to the flip-flop? This NOT gate will give 1 here, and this XNOR gate for a different XNOR gate will give 0. Now we know about the inputs to the flip-flop. Before applying clock pulse, first find input to the flip-flop. Then apply the clock pulse and follow the truth table. Now we have an input to flip-flop 1, 0. For JK flip-flop 1, 0, next state will be 1. Is it okay? Yes, sir. Now come to the last 1, 1. If we talk about 1, 1, then beta ji, for x1, y1, for x1, y1, for 1, 1, for 1, 1, for x1, y1, before applying clock pulse, first find input to the flip-flop. Remember this line. This line is sufficient to solve 90% of the gate questions. 90% of any competitive exam questions asked from the sequential. Before applying clock pulse, first find input to the flip-flops. Jitte bhi ho. It doesn't matter how many flip-flops are there. Is it okay? Before applying clock pulse, first find inputs to the flip-flops. Then apply clock pulse and follow the truth table. Now please observe for 1, 1, what happened? For 1, 1, before applying clock pulse, first find input to the flip-flop. Is Y is 1, then onto the J we are getting 0. 1, 1 equivalence NOR gate is a equivalence gate. Means NOR gate will give output logic 1 whenever the inputs are equal. It is available for 2 inputs only. So for 0, 1, onto the JK flip-flop, and if the clock appear, next state will become 0. That is what we want to design. You want to invent a XY flip-flop. You want to invent a XY flip-flop. QN bar, QN 1, 0. And now you have designed the XY flip-flop, which gives QN bar, QN 1, 0. But there is one very important thing that we have to consider. That is the logic gate delay. If you are going to design this flip-flop, then okay, it can be designed. But what happened here, one logic level delay is increased. And when we see the inputs, and outputs, we are getting 4 states only. That is 0, 1, QN and QN complement. So it would be better to go with the JK directly. Great, sir. How many of you are able to understand? Because you can design any desired flip-flop, but ultimately what happened? It increases the delay. How many of you now able to understand, beta ji? Great. You can design any desired flip-flop from any available flip-flop. It means you can do conversion of one flip-flop to another flip-flop. You can do conversion of one flip-flop to another flip-flop. Let's try to do the conversion of one flip-flop to another flip-flop. Okay. Yes, sir. Let's try to do the conversion of one flip-flop to another flip-flop. Convert D flip-flop into T flip-flop. So can you convert D flip-flop into T flip-flop, beta ji? What is the required flip-flop? Required flip-flop is T flip-flop. Available flip-flop is D flip-flop. So to construct or to design any desired flip-flop, first we need to write down the characteristic. First we need to write down the characteristic table of required flip-flop. Characteristic table of required flip-flop. So characteristic table of required flip-flop. We want T flip-flop. So T, QN and QN plus 1. Characteristic table of required flip-flop. How many of you able to understand, beta ji? First of all, we need to write characteristic table of required flip-flop. Yes, sir. So input T may be 0, may be 1, and present state may be 0, may be 1. Present state may be 0, may be 1. Now please observe, beta ji, how to write T flip-flop. We all remember the T flip-flop truth table. For T is equals to 0, it will be in the hold state, and for T is equals to 1, it will be in the toggle mode. So hold state means whatever QN we will get same, and toggle means Qn, then Qn complement, Qn, then Qn complement. Is it okay? Now, next step is to construct excitation table of available flip-flop. Next step is to construct excitation table of available flip-flop. So available flip-flop is D. We have to convert D to T. So required is T, available is D. So available is D. Is it okay? From characteristic table of required flip-flop. So now please observe here. We need to write excitation table of available flip-flop from characteristic table of required flip-flop. Please observe beta ji. For 0, 0, for present state 0 and next desired state 0. For present state 0, for present state 0 and next desired state 0. We all know D flip-flop is a transparent latch. Also, we all know about the excitation table of D flip-flop. Excitation table of D flip-flop 0, 0, 0, 1, 1, 0, 1, 1. So 0, 1, 0, 1. Now for present state 0 and next desired state 0. The excitation needed on D flip-flop is 0. D flip-flop is a transparent latch. You can just copy Qn plus 1 and paste on D. You will get same. For 1, 1. For 1, 1 we get 1. For 0, 1. For 0, 1 we get 1. For 1, 0. For 1, 0 we get 0. How many of you able to understand beta ji? Great. Now please observe. We can write the excitation equation of available flip-flop. So I am writing excitation equation of available flip-flop. Excitation equation of available flip-flop. So available flip-flop is D flip-flop. Excitation equation in terms of present input and present state. In terms of present input and present state. I am also doing the minimization. Now please observe, we are getting high onto the binary. If we observe T0 Qn0, this is the binary of 0, 1, 2, 3. So 0, 0 is the binary of 0, 0, 1 is the binary of 1. We are getting logic 1 onto the binary condition of 1 in terms of TQn, where T is a MSB and Qn is a LSB. 1, 1, that is onto the binary condition of 2, we are getting 1. These two we are getting 0. So D will become T Qn bar plus T bar Qn. It means T XOR Qn. Great, sir. So you can implement T flip-flop from D flip-flop. Is it okay? You can implement T flip-flop from D flip-flop as T XOR Qn. Next is your circuit implementation. The available flip-flop is D flip-flop. Available flip-flop is D flip-flop. We want to implement T flip-flop. We want to implement T flip-flop. So T flip-flop can be implemented from D flip-flop as D is equals to T XOR Qn. Your flip-flop get implemented. How many of you able to understand beta ji? So can you now design any desired flip-flop? Can you now design any desired flip-flop? Great. How many of you able to understand up to this part? Please let me know by writing in the comment section. How many of you able to understand up to this part? Please let me know by writing in the comment section, beta ji. How many of you able to understand up to this part? Please let me know by writing in the comment section. I am giving one homework to you where XY flip-flop you need to design from JK and D both. The given truth table of the JK flip-flop is Qn bar 0, Qn 1. Okay. How many of you able to understand up to this part? This is a gate question. So you can have a practice on this question as well. You can just stop the video, take a 2-minute pause and you can try to solve it. Okay. Yes, sir. So hoping up to this part everything is clear. Now you know about the flip-flops and conversion of one flip-flop to another flip-flop. We will meet in the next part and discuss about the registers and counters. Till then, please try to revise the content that already covered and go through the PYQ of your branch. If you are from CS, you have to go with the CS PYQ questions, electronics and electrical PYQ question. If you are from electronics, you can go with the CS, electrical and electronics PYQ and instrumentation PYQ. Is it okay? For instrumentation, need to go with all the 4 branches PYQ. Digital is already 4 branches are covered. So, and also the papers of CS and ECE will occur in the different sessions. So, lot of questions are there. Is it okay? And all the questions are non-repetitive type, but the concept more or less is same, but the questions you will feel new. Okay. So better to go with the standard question already asked in the gate PYQs. If you are able to solve them, then it will be very easy to solve any question new which is going to ask in the future exams, okay, in your gate 2027 as well. Hoping you have enjoyed this session so far. So thank you everyone, lots of love. You can connect with me on my Telegram, Varun sir @PW. I'm trying to give you. First, let me save this, otherwise let's go. Okay, so wait just a minute. I am giving you the scanner where you can directly connect with me on my Telegram, where you can ask any question, whatever you are unable to solve. And also you can post your doubts, any kind of doubts related to the subject, you can post there and you will get the your PDF on the on your Telegram only, okay? It is not coming. You can scan this QR and get connected with the Telegram, okay? Where you will get all the updates. So thank you everyone. Hoping you have enjoyed the session so far. Lots of love. Good night.